So I'm going to give you a whirlwind tour of 3 different data archives in front of me. There are quite a number of these, so I'm trying to give you more of a tip of the iceberg of what you can do as opposed to tell you everything there is. When I agreed to give this talk in this time slot, I neglected to realize that I was at the AAT yesterday at 3 a.m. So that means that if I sound half awake, it's probably because I am. My apologies. The notes which I'm using are available here, so if you would like to follow along, you can. I'm going to give you a slide that involves no slides, a talk that involves no slides. There we go. Just a couple of live demonstrations. So, now that I've had my photo taken for Twitter, Facebook.
I'm doing the Twitter photos, yeah.
Oh, even better. So I'm going to start out with a problem that I think we've all had, which is I've got a paper. This is not a shameless plug for myself, I swear. I have a paper and it's got some data in it. And I'm curious to just make sure that I understand the results and that they've done them right and whatnot like this. Bit of a question on reproducibility. So I go through the paper and there's various plots and whatnot, and at the end is the all-important tables with all of the data that have been used to make the plots in this paper. Now, put your hand up if you have manually typed numbers from the data table in a paper into a text file to then plot. Yeah, quite a lot of people put their hands up. So I'm going to show you a way that you can do that without having to do that, which hopefully I was quite surprised at how easy this actually is. So let's say that I want to plot just a couple of columns from this paper. So I want to plot say the luminosity of H alpha, and actually in a separate table somewhere there is also gas mass. Oh, sorry, it's in this table. It's just on the end. So we've all heard of Vizier. Which I was quite surprised to discover that it's also has a completely different definition. But Vizier is basically the astronomy table archive or catalog archive. And so I'm just going to type this paper in, Green 2014, and does some search results have popped up. And a couple of lines down, I actually see the paper that I'm interested in, so I'm just going to click on this. And there are a variety of tables popping up. I can do some kind of selection of things in the tables and whatnot. I know I'm particularly interested in this one that has the basic star formation properties, because that's table 4. So I'm going to click on that. And then, I just kind of want the data, so maybe if I just click submit. And there we go. Okay, so here are the numbers from the paper. Now, I've picked this paper because I know that I did absolutely nothing special to get my data into Vizier. All I did is submit my paper to the journal and forgot about it. So keep that in mind, in that this stuff just happens, and so you get this access. Now, I want to produce this plot of these 2 columns. And, if I rummage around, looks like maybe I can download it somehow. There might be like CSV or something, I don't know. But maybe there's an easier way. Maybe I could just load this data directly into my tool of choice. How many people here use Python? Most of you, okay. I'm impressed. So, what I'm going to do, I'm going to search for something called an API. Now, an API is an application program interface, what it stands for. It's basically a way for computers to talk to other computers, other programs. And one of the first hits that comes up here is this Astro Query Vizier thing, which doesn't actually say right here it's Python. Maybe I should put Python in here as well. It is Python. And so bit of documentation, and you know, I could read all this, but I'm kind of eager because I've only got a few minutes to write this talk. So I'm just going to play with it. So let's get Python up. Is that reasonably legible?
You're a little dark, I think. Actually, a little dark.
Better?
Yeah.
So what was that thing I had to type from Astro Query Oh, well that's not very helpful, it's given me an error. And what it's telling me is that, oh, I don't have a module named this year. Well that's easy enough to fix, so I'm just going to exit IPython. And if you've got a reasonably recent copy of Python, so I'm actually using Anaconda Python, that means I have this command called pip. Pip is the Python package manager, and it's very good at going and installing things you haven't got. So, successfully installed, brilliant. So, start up Python again. I'm just going to add an extra command here that gives you the plotting tools as well. It didn't like that, did it? There we go. Okay, so now what was that command again? From Astro Query Vizier, import Vizier. And think about it for a second. Okay, there we go. Okay, so what can I do with this thing? So IPython, if you haven't noticed already, has tab completion. So I just type Vizier dot, and then I want to know what this thing does. And it looks like there's this thing, git catalogs. That sounds like what I might want to do. Now, if I didn't know what this does, I can put a little question mark at the beginning here, and it'll actually give me a bit of documentation. It varies a bit. Some things are a bit thin on the ground for documentation, some things are better. But let's just have a go. So go back to my catalog, and it seems to have this ID along here, which is actually pretty easy to imagine. It's just the journal volume number and page and whatnot. So let's just put this in. Whatever it's going to return, I want to save. Okay, so it's given me something called a table list. I have no idea what that means. And it's got one table in it. Okay, so what can I do with this thing? Now, it took me a minute. When I got to this stage this morning, I kind of thought, oh, now what do I do? But it's a list, so let me just pretend it's a list. So if I say 0, it's going to give me the first item in the list. And okay, now this actually starts to look like the data I'm looking for. So maybe I'll save this a separate variable. And what can I do to this thing? Oh, wow, I can do lots of things with this thing. Column names. Maybe that would be useful. Let's see what the column names are.
Yeah, can I stop first? I'm a little bit behind with the kind of thing.
Behind with in
just a few commands in what you were doing.
So if you do want to follow along, which if I were you, I would try it later. But if you do want to follow along, all the commands I'm typing are actually in the notes. So, okay, I've got my list of column names, and there's one of my columns, mgas, that's one of the columns I wanted to plot. And log h alpha, IFU h alpha, sounds reasonable. And of course, I can always, if I'm not really sure, I can always go back over here and kind of look and see what were the columns named over here. It actually even gives you all the details. It's funny reading your captions on the web page. So what if I can just do something like ask for one of these columns? Oh, okay, so there's the numbers from column, looks like. Well, let's see if we can plot these. So I'm just going to use matplotlib because it's convenient, not necessarily because I like it. What did I say? Cat, mgas, that was one of the column names. And the other one was like L. Okay. So I looked at this and I thought, well, I think that's what I want, but you know, which axes did I put which way and whatnot? So just have a quick look over here. And if you notice, I've done the H alpha flux measurements are in log units. So there's a kind of 40, and then over here off the edge somewhere is m gas. Apparently these are in units of 10 to the 9 msons. So you can work out, well, okay, this must be the H alpha luminosity, and this must be the gas mass. And voila. So without typing any numbers anywhere, without downloading any files, etc., I basically am able to pull the data from this paper and produce a plot from it. So before you type numbers by hand next time, think about using Vizier and think about possibly using this Astro query thing. It seems to work. I make no promises because I've just installed it, so I have heard about it before, so that was encouraging when I saw it pop up. So, are there any questions just on that?
Sorry, you provided that data table with verified to Vizier.
So, no, I didn't. That's partly why I chose this paper, was because I actually had done nothing special. All I did was submit it to MinRes and forget about it. So I don't actually know what Vizier does. They've actually, I mean, an interesting question might be, you know, has some poor soul actually keyed these in by hand, in which case maybe they've got typos in them or something. I certainly hope not. I doubt it, considering how much, you know, effort astronomy has available for these kinds of things. So what they've probably done is, you know, maybe they have an agreement with the journal to get the data from the tables directly from the journal, or something like that. I don't actually know. But it goes to show that you don't necessarily have to have done something special to get the data in. Good question. Any others? No. That was a very quick kind of whirlwind tour of that. But like I said, there are some notes online if you want to try and do it later. So the second one that I thought would be appropriate is the Gemini archive. Might be our only access to Gemini for a little while. It's through the archive, so a good idea to do that. So in this case, from the Gemini archive, let's think a little differently. So I might be more interested in, so it's a telescope archive, so maybe I'm interested in downloading the data that I forgot to take home from the telescope, or maybe I lost it. We've all got data laying around on disks and whatnot, but these days, thankfully, almost all telescopes have some kind of data archive, so if lightning strikes your backup and you realize that you no longer have a copy of your data, you can always re-download it. So Gemini archive, first hit apparently. Okay, so the data I'm looking for is actually some data from my thesis. I won't bother to pull up my thesis because then more than 2 people would have read it. The world might implode. but I know the coordinates of my target. So I'm interested in this galaxy for my thesis, and I know the coordinates. So type this into the RA field, hours, minutes, seconds, sounds good. And look at the deck too. Okay, well, it's been observed with juniors. This is more recent. Don't know whose science. Actually, I do know whose science this is, but it wasn't not the form I'm looking for. So I'm looking for NIFS data. So maybe if I put in another constraint here, NIFS. Okay, here we go. So here's the NIFS data was LGS AAO time. And so this is pretty slick, right? I've got, I can click on, see what I can find. I click on one of these files. That gives me the header, it looks like. If I go back over here, looks like I can download the file. Also do a preview. It's not a very useful image of a raw frame, but I guess if it was an imaging camera, that might be really useful. So I can, this is really quite clever. So, you could select some of these files and download them manually. Or at the bottom, you can also just download all of the files, and it tells me conveniently that they're about 1 gigabyte. And I thought this was quite interesting. This data is always available at this link. So there is a link. It's popping up in the very bottom, so I'm sure people can't actually see it. But it's giving me a little link that apparently always and forever will point to this data. So it's very convenient if you have gone to the trouble to find this piece of data and then you need to email it to a collaborator to say, this is the data you need to download, or to a student or something like this. You can just cut and paste this link and email it to them, and they'll be able to find the same data that I'm looking at. So, fair enough, that's pretty clever. Let's take this a step farther. So, what if I have a slightly different situation? Maybe I'm trying to write a data reduction pipeline or something, and for whatever reason I want to just download these data directly into the piece of software that I'm working with. So I've got some software, I want to download this data. They've got some very nice help. I found it convenient, but it was reasonably succinct. One of the items here is accessing the archive from scripts in the command lines. Maybe I've got a lot of files I want to download, or I want to do something clever with the querying or something like this. Click on this. Many URLs can be constructed easily by hand or programmatically. Oh, that sounds like what might be what I might want. Further details are provided in the application interface. So here we see that magic API word appearing again. Again, there's lots of text, I could read it. But since I've already been to this page and scrolled through a bit of the text, what I do know is down at the bottom there's actually a Python script that will go and get information from the archive. And so there's a simple list. I give an example of the output. This was far more, the second one, more details of the files using something called JSON summary. This looks really useful. Looks kind of like an observing log might look. So maybe I'll try this. So I'm just going to take their example and copy it straight from the web page. I'm going to go to my IPython terminal. IPython has this special command, magic command, so you put the % symbol in front of it, paste, and what it does is it will take the stuff that I've just copied and it will paste it into the terminal. Now you might say, why can't I just Control-V right here? Sometimes you can and sometimes you can't. Those of you who have played with Python a bit know that it does something very strange, and that the amount of indentation is important for the programming language. And so often if you just Control V here, you get an error that says there's something wrong with your indentation. But if you use this paste command, it will sort it all out. So I'm going to do that. Actually nicely pre-printed out what I pasted. And then it's thinking, and okay, so it's gone to the archive and gotten this data. It's actually gotten a bit more, maybe not, than was in this list. Okay, so that's kind of useful, but of course that's not my data. That's not very helpful. So I'm just going to get text editor here and paste that code in here. And what you see, a list of the object files taken with Gmos. Oh, okay, so somehow this is identifying, this looks interesting, so there's maybe the instrument and the type of file, that looks like a date. I happen to know, because I've read a little bit of the documents, that actually the orders of these things doesn't make any difference, which I thought was very clever of them. So I don't have to, worry about, oh, did I get the right parameter in the right order or something like this. And I found it to be kind of intuitive, actually, surprisingly intuitive. So, like, for instance, let's say I happen to know that my program ID is written on a piece of paper here somewhere. There we go. That's not it. GN 2008 Q18. Why don't I just try that? I'm just gonna, same thing again, copy and paste. Let's see if this will get the data from my program.
So does it actually copy the data to the memory, so it's like massive memory?
Well, so we'll get to that. That's a good question. What is it doing? Let's have a look at the code. So it's importing these two libraries in Python. URL lib, which probably gets data from the internet. And JSON, I happen to know, is a data interchange format, but that might not be obvious. So it's creating a URL which has got some kind of base name, and then it's got these search terms. So that's being stored in this URL, and then we're calling this URL open. Okay. That's being stored in this U, and then we're apparently reading from that URL, and we must be getting a JSON document, which makes sense because it says JSON summary up here, so maybe that's telling us something about the format. Then I guess we're closing probably our connection to this URL. And then this JSON doc that we stored, we're somehow decoding into this files thing. And conveniently they say this is a list of dictionaries, each containing info about a file. Okay, so for each of the items in this list, for FN files, looks like we're grabbing a few different bits. So assuming this is finished in the background, it hasn't, that's not encouraging, because it's done.
Just a quick question on the dictionaries. Is it reading some header automatically to find labels, or do you have to know the labels beforehand?
Which labels? These ones over here?
Yeah. So
yeah, I have no idea where this is coming from. So this is obviously, we can get this, let's see if I can work out why I'm not getting, I may not have enough tokens in here.
A or B after 2008,
I think. Good spotting. It's amazing how not just it can be a bit. Note about how I changed it. I don't remember how I changed it. But yeah, I think that's probably what we've done wrong. which probably explains it's probably not returning anything. Let's try that again. Okay, there we go. So let's look at this files thing. So it's a list. We know because it told us, but also because it's surrounded by this square bracket. And a list of dictionaries. So if I want, let's just find one of the items in this list. So these are all of the keys to this dictionary. Top here. So looks like it's got a bunch of information, probably coming from the header. To answer your question, this is what the Gemini archives give me. So I haven't specifically asked for header keyword or something like that. So yeah, I mean details of the implementation. I mean, an interesting question might be, well, okay, if what I wanted to know wasn't here, what might I do? Well, so what I could do, and this goes to one of the other questions that I heard, is it actually gives me this file name here. And so I could potentially download the file and have a look at what's in its header. So why don't we try doing that? Let's I'm going to modify this slightly. Let's say I just want the object frames. So the actual, or maybe I'll just put, I think I can do this. This is optimistically. Okay, so that seemed to work. So these are science frames, and maybe because I need to know more, let's get the header for one of these files. So what we can actually do is we could potentially just download the whole file. So let's see if we can figure that out. So if I go back over to the actual archive, and a lot of you probably won't be able to read this, but if I leave the mouse sitting over this download link, it gives me a URL, which is archive.gemini.edu/file, okay? And then it's got the name of a FITS file. So, well, that's pretty easy to reverse engineer. It looks like we just have to go to this URL with the name of the file we're interested in, and it'll give it to us. So, again, I could just download that file onto my computer somewhere, open Python and have a look. I can even potentially just have Python do it directly. So let's see if we can come up with something. So I'm just gonna just play with this file that we've been given. So file, and then we're gonna have to give it the name of the file name. So we already know that we've got something called files. I can run this files command and I get a bunch of stuff. And I could just take the first one in the list, and I need to know its name. Okay, so there's the name of the file. So here, and I can say, we'll just grab that name, and then we can add it on the end of our URL. Okay. Now, assuming this works the same way, so this is going to go and open this URL, which is now pointing to a FITS file, and we're going to read that FITS file. Now, think about what that means. If this is actually a FITS file, but I'm going to get a string of bytes, which is the FITS file. Okay? So I'll save that as this FITS bytes thing. And then I'm going to do a small bit of Python foo, fortunately. I really hoped I didn't have to do this, but it turns out that this thing is not quite completely implemented. So I'm gonna get this bytes IO thing. What this is gonna do, this is just gonna be a long string of bytes. In fact, let's just run this first half. See what it looks like. Here we are, we've got the file name, we're going to the URL. We're going to grab this thing, so in theory it's downloading FITS file in the background. Let me just see what I've got there. Okay, so that looks about right. I know it's about a 16 megabyte file. There's about 16 million bytes there. So that's encouraging. And actually, I mean, if I just looked at, I mean, we all know that, maybe we all know, that the first few bytes of a FITS file are just a string representation of the header. Okay, so, you know, I proved to you that there's a FITS file sitting there, or at least part of a FITS file. So the other tool I want is AstroPy as a FITS tool, which can read and write FITS files. So I'll grab that. And then I'm going to have to do something like fits.open. Now normally I would be typing in a file name here. Most people probably use this by typing in a file name. I can also type in I could also give it a file object. So if I already had a file open in Python, I can do that. So this bytes IO basically makes my string bytes look like a file object.
It's bytes.
It is FITS bytes, thank you. It's helpful in having a whole room full of people to debug your code as you write. Okay. What's this FITS file? Okay, this is starting to look like. So people who are familiar with AstroPy's FITS file thing will already know this works. Basically showing you that okay, there's a couple of extensions in this FITS file, and I could, for instance, grab the header out of the first FITS file, and there's the whole header. So again, I've actually, leapfrogged all the steps. I haven't done any downloading. I haven't done any, where did I put this file on disk? I haven't done anything like that. I've just gone straight to the archive, grabbed the file, and opened it straight into my tool. Now, if I was going to open this file 20 times in the process of, running some script, I probably would want to think about downloading it, because it's probably going to be faster to open it on my disk than to re-download it every time. But if I only need it once, it works. In the last couple of minutes, we're finishing 42? Cool. In the last couple of minutes, I will give you a very quick preview of a third archive. This is the AAO's new data archive. So this is not yet publicly available. We're currently in user testing with beta testing, is really the right way to put it, with the Gamma team and SAMI team. So I'm going to show you a little bit of the SAMI data that's available. Before I show you this, I might just take a quick kind of question, which is, what do you think the purpose of a data archive should be? What would you like to see out of a data archive? And I'll nip the obvious question in the bud by saying, well, obviously I want to be able to download the data. I forgot to bring home from the telescope. But else might you want to use a data archive for?
Searching.
Searching for things. So I want to know, maybe, is there a galaxy that has these particular characteristics, or a star with these particular characteristics? That's the kind of thing you're thinking of. Okay, that's a good one. That's a good one.
I'll just relate it back to previous and check that your observation has not already been done.
That's a really good thing you can do with an archive. You can check that somebody hasn't already taken the data that you need. It's very convenient to discover when you're writing your proposal. You don't have to go to the telescope. And more tags now check these things too as part of the assessment process. So it's also embarrassing if you then discover that you've gone to all the trouble to apply for this time and you get a note back saying, well, actually the data you need is on the con. Any other ideas?
Check to see if objects change.
Check to see if an object's changed. That's a good reason.
Just get complete data sets to check for reduction techniques as well.
Yeah, so maybe you need to check if you've gotten the same answer that the previous people got, so it's not uncommon to download someone else's data. It doesn't happen very often, but hopefully astronomy is repeatable. Those are all good answers. I'll take you through this and then I'll ask you, hopefully we come back to that question. So what this currently provides is basically a couple of ways of exploring the data. So SOV stands for Single Object Viewer. Don't ask me why we haven't spelled that out, but we haven't spelled that out yet. And I can just go and pick a random object. I could also type in the ID of an object for a particular one I was interested in. And it's going to chug for half a minute. One of the reasons it's still in beta is because we're still addressing some speed issues. What you're going to see in a second here is a selection of data on this galaxy, which has basically been provided entirely by the SAMI survey team, SAMI Galaxy survey team. So they've given the AAO basically a disk full of FITS files, and we're in the process of mapping that disk full of FITS files into browsable UI.
Is there some primary analysis results if I'm looking for low specific star formation galaxies?
Yeah, there is, and I'll actually show you that in just a half a second. So this is just rendered a velocity map and then a selection of line maps in different emission lines for this galaxy. I think I can also get an SDSS image for this galaxy. This is going to give me nothing because we haven't implemented it yet. Usefully, I could also just go and download this. So if I just want a FITS file of the velocity map of this galaxy, I can go and download it. And actually, this will support all of the same kinds of things that like the Gemini archive supports. So you can basically kind of work out what the URL might be for the data you're interested in, and then you could go and ask for the data for 2 dozen galaxies or something, either in Python or potentially through the user interface. In terms of high-level kind of science results that are available, SAMI hasn't actually given us any yet. That's still on their to-do list. But this is also cross-matching, so a lot of AAT surveys build on one another. And so in this case, actually, we have the whole of the Gamma catalog information here as well. And so I can, for instance, say I wanted to find galaxies in some kind of low-density environment. So this is actually building SQL for me because no one likes to do SQL. Galaxies that are actually in SAMI, because SAMI is a sub-selection, so I'll say it has data. And then this is something we're hoping to get rid of, but at the moment I actually have to know how to kind of connect the different tables of the data together. So currently to figure this out, you have to kind of dig through a database or a browser with the schema file effectively. Say I only want objects that where there's a cube available, and I can potentially put a selection here that's also on the density that I want. Ah, thank you. Claims there's still an error. Probably is an error. Which probably means when I try to run this, it's going to. I will make no promises that this will crash, because it is still very much in beta. But this should give us a. So this is some of the stuff that we're kind of working on in the background. This will become publicly available probably in July, where it's going to be hosting the first major SAMI data release. So we can think about going and playing with it there. Down the road in the long run, one of the things that might have been implicit in my question, what do you want to use data archives for? So you already saw that Vizier basically grabs your data for you, makes it available. It's really kind of convenient. No, that's not encouraging. Apparently there's none there. But another thing that we at the AAO would like to do is to increasingly provide support for all of the surveys that have been done on the AAT and surveys that will be done in the future on the AAT and other telescopes and instruments that we support to make your data public in an interface such as this. There is not a zero effort barrier to entry like Vizier, but we'll try and make it as easy as possible so that people can contribute the data. And actually, for those of you who've got long-term programs on the AAT, one of the things you've theoretically signed up for is making your data publicly available. So we're now actually coming to provide the tools that can do that in a kind of well-supported long-term way. I think I'm out of time, so I'll stop there and ask any last questions of you guys.
Great, let's start by thanking for any questions.
Oh, I just wanted to add that one thing, I mean, we're going to talk about Popcat and Python later, but the initial matching that you're doing with Vizier, you can actually do that as well with catalogs of position searches from in Popcat, which it looks, your initial search for Python looks very similar. So if you're really clever, you can actually link those up as well. Just do, say like, I want to find anything at its coordinates, what's here. So just keep in mind there's some of those.
So I'm always a bit suspicious of people who kind of give live talks about how much time do they spend preparing for those to present that. And so I should say, to kind of perhaps unintimidate you, if that can be used as a word. I started on this talk at about 10:30 this morning. So I sat down and I thought, I want to query this stuff from Vizier, how can I do it? And some web searching, some whatnot, all of this stuff basically came up, and I've almost taken you exactly through the thought process I went through this morning. So a lot of this is not nearly as intimidating as maybe it once was. Apparently there's more coming.
I don't know what the Popcat section is going to be on, but just FYI, you can get it.
Any other questions? So all of the notes from what I did are up here on this web page, and the magic URL is there. So that's somewhere useful.
Yeah,
Thank you.
I'll put it up on your program.
So I guess I have a general question. So Jim and I recently changed from the CADC, the Canadian interface, which was notoriously difficult to use, which seems like it's a drastic improvement. This idea of building URLs to query databases and opens up a lot of ways to accessing the data. Is that the way that general data archives are going? Not just catalogs, but actual fixed data?
Yeah. There's actually, ironically enough, it's built into like the HTTP standard from 20 years ago or something. Is this idea of actually, basically interacting with data through URLs much in the same way that a browser does. And so it is becoming more and more common. So for instance, one of the things I didn't say is that in this view here, where it's in a minute, this is going to pop up a little image of the data. This is actually being retrieved from the website. So the website is creating a URL that's in this page, and then that page is then saying, well, I want the data from this URL, and it's going and grabbing it. And so it's actually requesting the data in the same way that you might request the data if you were going to write a script, and that's how the Gemini thing is defined. It's often referred to as kind of RESTful, R-E-S-T-ful. Programming geek language alert. But it is very much the way these things are going, is to basically make it very easy for you to programmatically access these data. I mean, you may not have, you probably weren't paying any attention, but if I go back to the Vizier URL, well actually it's put nothing up here, which isn't very helpful, because what do I type in there? A bit of fooling around. I think if I push this magic button, it will reload, and you'll see that it's got this horrid gobbledygook, which goes on and on and on and on and on. And if you're trying to write a script to do that, you're never going to get it right. And so yeah, there is very much the shift towards what Gemini has done, which is to make this as simple and as straightforward as possible. Interestingly enough, this whole thing is actually hosted on Amazon